Good day, generators. It's the 28th of March, 2024. Today, in Moment in Motion, more about the higher orders of acceleration, infinity, and down. Infinity is a large number among numbers, generally considered the largest number. Usually enters the language shortly after socialization in words. When talking about math and numbers, someone will come up with a relative order of things like 10 times as much, 100 times as much, 1,000,000 times as much. And somebody will bring out infinity many, which is always greater than any of these other orders, so that's why it's so great. There's been lots of talk here, of course, already about infinity and the mind, as with regards to, for example, that being a title of a book by Rudy Rucker, who wrote a book called Infinity in the Mind, which gets into a lot of the thought experiments about it, the parables, the foibles, the paradoxes, and what there aren't of it. It's just the largest number. It's the grandest. It's the greatest. It's the most multitudinous. There's nothing with regards to quantity that it isn't. It's infinity. It's the one of the greatest numbers, along with 0 and 1. Basically establishes the entire idea of inversion for quantities between 0 and 1 in the magnitudes, and quantities close to 0 and their inverses quantities that are large. So when you add infinity, you got things that are large, things that are complete in terms of the division and partition of things to 0. The inverse, the reciprocal of large, small, infinitesimal, the iota values, or variously in any kinds of notions of infinities have their inverse and reciprocal infinitesimals with regards to the analytical character at all, the real analytical character, these not real numbers, though they are only in the space of real numbers, especially infinitesimals. Between 0 and 1, there's nothing in the continuum except real numbers. So that there is a model of a continuous domain in the same space as a complete ordered field where everything is divided down into fractions, results that these beads on a string, the iota values, are as well real numbers. They have real analytical character with regards to measure and the measure problem. So anyways, that isn't really about infinity and all its higher orders of acceleration, except it has arbitrarily non-zero, higher and 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 higher orders of acceleration, all the way to infinity, or in the unbounded, we'll usually say as standard. So when trying to figure that out, then. So from the previous talk, there was quite a bit of discussion about just, the formalisms and then the laws, which were basically Galileo's laws. I mean, if you have Newton's next law is like, well, force equals mass times acceleration. That's kind of his definition, we'll leave that out. And then the third law is like universal gravitation, mgg over d squared, inverse square, proportional to masses, gravity, universal law. Those aren't so much just so relevant here, except with regards to just the classical moment in motion of rest in motion with regards to changes of that at all. There gets into these notions of the forces and fictitious forces and pseudo forces, where there's the centrifugal or the centripetal. The one or the other is considered fictitious in terms of how it's perceived as an acceleration. It's sensed. The pressure is as of a gravity force in G's is force or measure of acceleration. Has that there's various reasons why it's broken down in the definitions. And it's one way or the other. Yet at the same time, what it is in the real side of it is kind of at odds, kind of with how the definition and extension carries out. It causes a lot of angst, if you ask me, in stuff like physics classes when you're learning these things. And it's like, okay, I've learned all these formulas, I've absorbed all them, and they reflect what I can compute in one dimension, linearly. But then as soon as it starts coming around, it's like, what does this quantity do when it makes an angle, when it makes a turn, when it turns, when its space is curved, when it enters a rotation, when it is the centrifugal? And the answer is that, well, it's like, it's just kind of pointed inward. It's inverted to what you figure, and then instead of the rotational frame being free inside, it's just kind of set inside. Whether things are independent are like this. And it's funny because in the Sky Survey today, they're looking like the whole solar system is a free rotation. And so that it essentially ends up that it's not expanding outwards. It's not like the behavior usually of the ice skater who's able to control the speed of the rotation by changing their arms distance, and thus the fulcrum as about the constant levering of the center of momentum and the moment, angular moment. Instead, it's just kind of spinning around as if the whole universe was spinning around it. It is back to this immobile celestial spheres bit, only insofar as that inside the rotating frame is free. Everything else is so far away that essentially is a constant to it. So that's not necessarily the same as like a rolling wheel, because Earth's well is always down. And the terrestrial and the acceleration, all that. But with regards to the spinning top, kind of is. With regards to the ring laser Sagnac effect, kind of is. So these are the things that get into why the whole dimensional analysis ends up being kind of at odds. Now, one thing everybody has heard of is G-forces. And so what is the G-force? Well, is the one gravitational force is basically Earth's force of gravity is called 1.0 Gs. It's a natural unit. And so it's funny because then acceleration, so 2 Gs is, whether it's in the same units of that, and it's twice that, or it carries out in the units that are different. See, this is funny because it's an acceleration, but its units when it's carrying it out is that G's are already kind of defined to be a little bit different than the higher orders of acceleration. So last time what we were talking about was how to define the higher orders of acceleration with regards to this kind of Jacob's ladder or the water chain or the dominoes, as it was described, the cascade, so that the higher orders come up and down in the order. Because otherwise the power terms that arrive from integrating them to keep their units the same end up also carrying up the inertial and kinetic terms, with the idea being is like, well, those are always just point down in the sense of the well model, or they always point up in terms of the spike model. This notions of the units, so that the dimensional analysis is getting involved both with changes in time and changes in direction. Vis-a-vis an areal terms, that a turn kind of turns through a number of different directions in a dimension. It's rotational. The whole idea here, this is all talked about, that's all kinematics. Kinetic is only linear, and it's just the impulse, and it's just the amount of energy and at an instant, at a point. Kinematics is all the related rates of the rigid rods assembling whatever results for the kinematics, the results for the inverse kinematics, how they're all connected together, have their joints and bones, the bones of the thing, of the inverse kinematics and kinematics, which helps us to relay what is the motions of bodies vis-a-vis how much energy is involved, how much inertia there is, how much momentum there is. When it's spinning top, does it gain momentum? Yeah. Does it gain inertia? No. these kinds of things get into the whole reason why it's classical mechanics is kind of underdefined. And so there's a couple different ways to help kind of bracket it up and frame it. And for general relativity, it's like, well, we have frames everywhere for inertial systems, and we have space in the big world outside, and geometries make this patchwork of the space that really just reflect gravity well, so that's just how they fall together. There's no dynamics at all. Just everything just falls together. Vis-a-vis that's spaces and frames. Spaces and frames everywhere. And then when there are dynamics, they change together, and the objects bring their space along with them. Yes, I know that this makes for a pretty simple explanation why the Galilean is what the linear looks like in real space terms, and that it's the same numbers add up in terms of the mass, and then with regards to how long it takes the echo to get back, it still takes the same amount of time. These kinds of issues in relativistic dynamics are as well related, although the idea is to yet put those off, the high energy unification of forces and relativistic dynamics in the highly nonlinear, back down in the classical mechanics in simply the unlinear, which does, however, have eventually, it must, some careful, distinct, and succinct definition of a dimensional analysis that relates these things in terms of their units. As discussed last time, whether those were involved with dimensionless constants, as about the dimensional resonator, which is a word at least invented yet last time. It doesn't quite have a definition established, except that it makes it so that when there's higher orders of terms in like an expansion of a formula into an infinite series, that the dimensional analysis just doesn't also as well go out into the infinitely many terms, their orders, which is not really a thing, except insofar as they do come back down, that it does get reattached in the dimensional analysis somehow in terms of those higher orders in the expansion, like E equals mc squared, the kinetic energy of a particle according to relativistic velocity. That's just the first term of the infinite series. The higher orders are not in the same units. The interpretation of that gets into is usually described as the multipole moment. So a moment usually has like a pole. It's like a spinning top. It's got a pole, and any axis changes there is about it, whereas the rotation is around it. Multipole moment is basically the idea is like, well, it's kind of like a three phase or three state, which results it kind of it tips one of the ways. Well, still it's kind of just seems like the same thing. These are the kinds of things. One moment.